Hello, my name is Sara Rostami. I'm a master's student majoring in AI at the University of Tehran in Iran. Last summer, I participated in NMA's Computational Neuroscience course, and I really loved it. So without further ado, let's jump right in our today's tutorial. So as you recall, with simple linear regression, we had only one model parameter, theta. But with multiple linear regression, we have d+1 model parameters, with theta 0 being the intercept term and theta 1 to theta d being the coefficients of the features of our input data. So you can see the vector notation of this equation here, and you can also see the matrix form of this equation here. And X is usually known as the design matrix, which contains the feature values of our of every single data point that we have. So for testing this model, first, we're gonna generate some random data points in a two-dimensional space. And our goal here is to find the optimal vector parameter theta hat. And for achieving this optimal vector parameter, we're gonna use the ordinary least square estimator, which we're gonna implement in this cell. And for implementing this function, we're going to use the equation that we had above right here, the ordinary least square estimator. And we're going to write this using Python's NumPy library, and here. As you see, we have the theta hat vector here. With the theta hat, we can now calculate the mean square error of our model, which can be calculated here. And as you see, the MSE of our model is 0.91. So by running this block of code, we can also visualize our model. And as you see, this is the plane of our model, and you can see the distance between each of the data points and our model's plane that make up the error terms of our model. So the main focus of this tutorial is polynomial regression. With real data, like brain data, we expect more complex behavior. These more complex behaviors cannot be modeled by simple models like linear regressions that are only capable of modeling linear relationships. With polynomial regression, we can do so. Polynomial regression fits a non-linear model with a polynomial equation like this. As you can see, the main difference of this equation with the equation of multiple linear regression is the order of our X values. So for testing this model, like before, we're going to generate some random points in a two-dimensional space, and then we're going to make the design matrix for our polynomial regression. For making the design matrix, first we're going to stack our design matrix with ones for our intercept terms, and then we're going to stack it with our input data powered by the order that we desire. We're going to achieve so by going through a loop starting with order 1 to our desired order. So let's test this out. And now this is our design matrix. And thank you for watching this tutorial.